Welcome to Nature Science Academy. It's the introductory part of upcoming video series on nuclear physics. Nuclear physics, the study of atomic nucleus. It's entirely different from atomic physics, in which we study about the atoms, interaction between the atoms, their interatomic bonding to form simpler molecules to complex compounds. But here, our studies get deeper into the central core of the atom called nucleus. Before getting into the subject, we shall discuss about some historical events, which is the reason for emergence of new branch of physics about 100 years ago. Because more than a theoretical physicist, experimentalists worked hard on their research without knowing that they will get their result or not. Even in some cases, they worked for a number of years to get only a minimal clues. So it's more essential to realize them before entering into the subject. The timeline starts in 1896 when Henry Becquerel discovered radioactivity. A peculiar thing to accept at that time. Becquerel's real life incident tempts him to found the radioactivity. It's the time when Rontgen discovered X rays he was most admired on it. His interest in phosphorescence tempts him to carry out some experiments to make a connection between phosphorescence and newly discovered X rays. He thought that phosphorescent materials may emit X ray like radiations when illuminated by sunlight. But he found to get the darkened images of objects placed in between the phosphorescent material and photographic plates in the presence of sunlight. Unfortunately, two consecutive cloudy days interrupt his experiments. On the days, he placed the phosphorescent salt, the potassium uranyl sulfide, along with the Maltese glass and photograph plate in his cabinet. He was surprised to observe the darkened images without any light source. He claimed that the penetrating radiation emitting from uranium salt itself is the reason for image formation. Later, he published 7 research papers on radioactivity and continues his experiment in different aspects. At the same time, the radioactive elements like thorium, polonium, radium are discovered due to the intensive work on radioactivity by the preserving couples Pierre Curie and Marie Curie. Finally, in 1903, Becquerel shared a Nobel Prize along with Pierre Curie and Marie Curie. Radioactivity, the spontaneous emissions of radiation. In 1911, Rutherford, also called father of nuclear physics, get into the game. He gave us the planetary model of atom. It's similar to our solar system, hence the name planetary model, by his famous alpha scattering experiment, along with his collaborators, Geiger and Marsden. They are evident to found that most of the alpha rays passing through gold foil are being undeflected. Some of them are deflected at minimum angles. Very few occasionally deflected nearly 180 degrees. It's because of the presence of central, massive, and a positively charged particle called nucleus. Most of the remaining areas are empty with negatively charged electrons, which revolves around the central nucleus. Protons, which were discovered on 1909, were accepted by 1920. Like that, isotopism were accepted after 20 years. By 1932, and neutrons were discovered by James Chadwick. Okay, we shall get into the subject right now. On the basis of theory frameworks and experiments, we can classify nuclear physics into theoretical nuclear physics and experimental nuclear physics. Here we are going to see about the outline of topics that we are going to discuss under these two major categories. In theoretical nuclear physics, the first topic is nuclear properties. Some of the nuclear properties that we are going to discuss are nuclear charge, radius, sequence size, their mass, binding energy, angular momentum, magnetic dipole moment, electric quadrupole moment, parity, isospin. From these nuclear properties, some predictions are made on nuclear models, and some of the proposed nuclear models are liquid drop model, cell model, collective model, Fermi gas model. In liquid drop model, atomic nucleus is compared to a liquid drop in its properties. In cell model, the energy levels of nucleons are compared to the electronic cells of atom. Magic numbers are explained here. And then in collective model, the name itself says that it is a collection of best assumptions made on liquid drop model and a cell model. Another one is Fermi gas model. It features us that nucleons are quasi-freely moving within their nuclear volume. The next topic is radioactivity. Radioactivity is the process in which unstable atomic nuclei liberates energy by emitting the particles or radiations. And are of three kinds. They are alpha decay, beta decay, and gamma decay. Alpha particles are helium nuclei are emitted in alpha decay, and electrons are positrons along with the antineutrino or neutrino in beta decay, and electromagnetic radiations are emitted in gamma decay. The next topic is nuclear reactions. In nuclear reaction, we are going to discuss about the nuclear fission reaction, nuclear fusion reaction, and the kinematics of these reactions. Nuclear fission is the process in which the unstable heavier atomic nucleus splits into two or more lighter nuclei by liberating energy and neutrons. Nuclear fusion is the process in which two lighter nuclei fuse to form a heavier nuclei by liberating energy. They are rare on Earth because of the requirement of high temperature and pressure. They are possible in some stars like our Sun. In next topic, kinematics. It involves the studying of energy and momentum of particles involved before and after the reaction, similar to the balancing of the chemical equations. In experimental nuclear physics, the first topic is nuclear accelerators. They accelerate the charged particles like protons or electrons to a very high speed for us to investigate the fundamental building blocks of matter, synthesizing new elements, study of these nuclear reactions, and exploring the fundamental forces. Some of the nuclear accelerators are linear accelerator, Van de Graaff generator, cyclotron, synchrotron. The next topic is nuclear detectors. Nuclear detectors are the instrument used to detect and measure the ionizing radiations such as alpha, beta, and gamma rays. Some of the detectors we are going to see are gas-filled detectors, scintillation detectors, and solid-state detectors. The next topic we are going to see in experimental nuclear physics is their applications. They have a vast range of application from the field of medicine to space exploration. Imaging and radiotherapy in medicine, power production in nuclear power plants, nuclear weapons in defense, determining the age of organic matter in radiocarbon dating, RTGS in space exploration. RTGS means radioisotope thermoelectric generators. Since 1961, RTGS are the main source for US space work. In the upcoming classes, we are going to discuss in detail about all these topics. Hope you all understand. Thanks for watching.